Okay, so let's make this example with utilizing the second method. Yes, you could see here that this is the strongly acidic pH. Yes, we have a nitric acid, and then we have arsenic acid. Okay, so using this second method, we can utilize the water particle and hydrogen cations H+. Okay, so let's start with the first oxidation state reaction. Arsenic 3 sulfide is considered to be insoluble in water aqueous solution. However, it is not insoluble in 100%. Yes, there are some ions. The number of these ions, the number of particles that appear in the water in the form of ions becomes greater through the reactions proceed. Yes, because there is a creation of arsenic acid, so arsenic atoms take part in a build of this particle of arsenic acid, and sulfur atoms are utilized to create sulfuric acid. So we can assume that we can write arsenic 3 sulfide in ionic form. Okay, so starting with arsenic. Yes, we have to remember that in the subscript here we have a 2. So we need to remember about this number already at this stage. So we have a arsenic cation. We have an arsenic cation with the charge equal to plus 3. Okay, so what else? What else do we have here? Of course, it's oxidation reaction. So there is a creation of what? Of this acid radical, acid residue of arsenic acid. I mean anion with oxygen. Yes, the charge of this anion is equal to -3. Okay, so if it is an oxidation reaction, yes, so the electrons must appear on the right side of this equation. So plus how many electrons? Please remember about this 2 in the front of arsenic atoms. And in this case, arsenic containing an ion, I mean acid radical. Okay, how many atoms? Arsenic from 3 plus to 5 plus give us 2 electrons. We have 2 atoms, so we have 4 electrons. Okay, we have oxygen atoms on the right side. We don't have oxygen atoms on the left side, so we need to utilize H plus and water particles. Water particles on the left side. H plus ions in the side where are the electrons, so plus H plus H plus H plus plus H plus, I'm sorry. Okay, we have 8 atoms of oxygen on the right side, so we need 8 particles of water. On the left side we have 16 atoms of hydrogen, so we need 16 hydrogen cations. Everything, in my opinion, is okay. The net charge on the left side is equal to plus 6. 2 times 3 plus give us 6 plus. On the right side, the charge is equal to 2 times 3 minus give us 6 minus plus 4 minus give us 10 minus. 10 minus plus 16 plus give us 6 plus. Okay, so the charge is correct. The charge is correct. What about the second oxidation reaction? The second oxidation reaction, so the reaction with sulfur. Okay, we have sulfide anion. 3 atoms of this anion with the charge equal to 2 minus. Okay, this is oxidation reaction. On the right side we have sulfide ions with the charge equal to 2 minus. How many electrons? As we said, it was 24 electrons because we need to have 3 atoms of sulfur. Okay, 3 atoms of sulfur on the left as well as right side of the reaction. Okay, what else? Of course, water particles and hydrogen ions. Hydrogen ions on the right side with the electrons and water particles on the left side. How many oxygen atoms do we have on the right as well as left side? On the right side there are 12, and it will remain 12 atoms. So on the left side we also need to have 12 atoms of oxygen. So we need to have 12 particles of water. If we have 12 particles of water, we have 24 atoms of hydrogen. So we need 24 hydrogen cations. What is the net charge on the left side of the reaction? 3 times 2 minus give us 6 minus. On the right side, 3 times 2 minus give us 6 minus. 24 minus plus 24 plus give us 0. So the net charge is 6 minus. Everything is correct. Reduction